All right, everybody. G'day. I think we should get started. There's lots to cover. So thanks for coming along to Dependency Resolution Deep Dive. My name is Daz DeBoer, but everyone calls me Daz. If you're Australian, you know why. It's just a standard translation. I'm a software engineer at Gradleware. Been there for a couple of years now. I've been using open source and developing open source for a long time. I was a committer on Ant for a while, and I did some early work on Selenium when it was still an in-house project at ThoughtWorks. Now I live in the Rocky Mountains in Kimberley, BC, which is pretty nice. So I haven't actually presented for probably about 8 years, so if I'm a little unpolished, forgive me. So what are we going to talk about today? So the whole goal is to help understand the nitty-gritty of what's going on when, oh man, see, I'm unpolished. What's going on when you have a bit of code like that, a repositories block and some dependencies declared, and how does Gradle end up with just a set of jars? You know, it's just sort of, I want to get into the low-level stuff. What actually is Gradle doing? So, what are we going to cover today? So, when I first thought about this, I thought I had a huge list, and then after trying to write a talk, I realized that's probably more like a 2-day training session. So I'm happy to cut a bit of stuff out. So the stuff up here I'm going to try to cover, the evolution of the dependency resolution quickly, an overview of the different types of repositories that Gradle supports. The bits in bold are the things I'm going to focus on more. So how repositories work, what do they do when they're resolving a dependency, and the Gradle dependency cache. So we've done a lot of work on caching, dependency caching in Gradle, and I sort of want to help you guys understand why things are working and why things aren't working. You know, so I'll get a little bit into controlling dependency resolution, like what you can do to affect dependency resolution. But Shapan Farber tomorrow about this time is giving a talk that will cover that in much more detail. Lots of use cases and really interesting things there. So I'll probably gloss over that a little bit. And finally, I just want to go over conflict resolution in Gradle, what it is and how it works. So I'm Australian, I live in Canada, so if you don't understand me because I've got a funny accent, just get me to talk slower because I get nervous and speed up. And any questions that you have, anytime, just yell out. Cool. So why do we want to understand dependency resolution? Why do we need to understand it? It's kind of funny because it's not something you need to understand to design your build so much as when things go wrong, it can be really frustrating if you can't work out what's going on. So having that understanding, like the low-level knowledge of what's happening there, can really help you to problem solve. That can help you work out why things are running slowly. That can be because dependency resolution can be a slow part of your build. So it can help you work out what's going on there. And it can help you to see patterns and more particularly anti-patterns in builds. Like an example is, I always put Maven local in my repository list because that'll make my build run faster, and that's just not true. I always use refresh dependencies because things don't work otherwise. I mean, those things is something you shouldn't need to do, so I want to help you try to understand how to solve these problems. Right, so just a little bit of history about Gradle and the dependency resolution. So when Hans started writing Gradle, I think probably 5 years ago, he chose Ivy as the dependency resolution engine. And it really was, Gradle was a build tool built on top of Ivy. All of the resolution was done by Ivy under the covers. Maven didn't have an embeddable dependency resolution engine at the time, and Ivy was definitely the best candidate for it. So nice thing about Ivy is that it does give you that I can resolve from Ivy repositories, from flat directories with jar files, as well as from Maven repositories. So it's a pretty good starting point, right? So, and then over time we've started moving away from it. We've started re-engineering parts of it. We've started pulling bits out, and so I want to just explain what we're trying to do. So why are we doing this? Why are we re-engineering dependency management? I mean, dependency management is fundamental. It's so core to almost every build system that it's something we want to keep on improving. We want to keep on making it better. We want to make it more usable. We want to make it faster. We want to make it solve use cases better. So, and Ivy was sort of helping up to a point, and then it started getting in the road. It started causing us more issues than it was solving. You know, we wanted to make we wanted to use HTTP client to download things rather than java.net.url. That's because then HTTP client gives us all sorts of cool stuff. We can do head requests, we can do get requests. There's lots of cool stuff we can do. Ivy didn't make it very easy for us to do this. We tried, we struggled, and we found there's static state in there, and there's some implicit configuration, and there's just some design choices that were made that made it really hard. And we decided, dependency resolution is so important, we need to take ownership of this. So we just sort of bit the bullet and started piecemeal re-implementing pieces, the bits that really mattered to us. Basically the difficulty to extending was one of the reasons. Another reason and maybe it wasn't a driver, but it's kind of it's nice that this is happening, is it's incredibly flexible. Like it's got so many, you can pretty much tweak every possible thing you might want to in an Ivy dependency resolve. You can set the conflict manager, you can say what the latest strategy is, you can change all sorts of things, you can implement your own dependency resolver, which is amazing, right? But we don't have integration tests for any of this stuff, we don't have documentation for this stuff, we're getting reports for things that we broke and we didn't know these features existed, So, I know Ivy pretty well, but not well enough to know every little tiny edge case. So it's going to be, I guess one of our goals is to have a well-known set of use cases we solve and not a infinitely configurable, infinitely flexible tool that solves everything, but we don't quite know how. So it's kind of where we're heading with it. So where are we up to so far? One of the first things we did was Adam, who's the sort of the lead developer on Gradle, went away on one weekend and completely rewrote the dependency resolution engine, which is just mind-blowing. But anyway, so basically that was the thing that does conflict management, the thing that does transitive dependency resolution, just kind of the high-level architect of it. So that was the first step, was to basically do that. Another thing we did is we basically got some of the core repository types, so what was traditionally a dependency resolver in Ivy, and we started pulling the code in, refactoring it, cleaning it up. So things like using HTTP client for all of our resolution, introducing abstractions around repositories and things like that. And we've added a brand new caching engine and algorithm there. So, and that was all. And these were all driven by real use cases. So that's where we're at. That's what we've done. What we haven't done is Ivy's still there. Like we've got a lot of Ivy still, and it's still valuable to us. It does a lot of work for us. So certain things are unfortunate. There are places in the Gradle API where Ivy types are returned. So in order to maintain backward compatibility, there's no way we can change that. So these are sort of little blocks that stop us from going further. And then there are certain use cases that still require an Ivy dependency resolver to be used natively. The first two use cases there are ones that we've solved in the last 6 months. So it used to be you couldn't do a M2 compatible Ivy repository. I'll explain what that means later, but you can now. But still, if you have a local file system which is actually on, say, an NFS mount or something like that, and it's slow and you want caching, unfortunately Gradle doesn't yet give you a solution to that. So you can dive in, grab a native Ivy dependency resolver and do it all yourself. Same with SFTP and SSH support. It's not that we can't, we just haven't got around to implementing those things yet. Right, so repositories is pretty key to. Repositories are pretty key to all dependency resolution. So I just want to go through the types of repositories that Gradle has, mainly the Maven and Ivy repository formats, and talk about their differences and similarities. So yeah, so from the
slides aren't matching, so if you could upload those when you're done, that'd be great.
I did upload them, but quite recently. Sorry?
I noticed that it seemed to have jumped about 3 slides.
Yeah, okay. Apologies, I did. I'm not organised enough to have my slides ready on Monday when I was asked, so I did upload some, and then even this morning at 5 o'clock I was still changing them. So I did upload them this morning, so I think your iPads can refresh them or something. So, but this is the truth. Everything else, don't believe. All right. Yeah, part of it was the talk was going to go for 2.5 hours if I kept them how they were, and I figured people wanted to head out elsewhere. So, So yeah, at the most basic level, it's pretty simple to configure a repository, an Ivy or a Maven repository. Give it a different URL, HTTPS or file as well as HTTP. It's pretty straightforward. But a Maven repository, what is it about a Maven repository? So got a fixed layout. So Maven basically says this is exactly how our repository should be laid out. It's kind of nice actually, it makes things nice and simple. Any group ID, so any what we call a group ID, what Ivy calls an organization, gets mapped from a something dot something dot something to a something slash something slash something. So that's the directory structure has to be done that way. It includes this special file format called, it's a Maven metadata file, and that's used for listing everything that's available, listing all the versions that are available, as well as handling snapshots. So basically finding what's the latest snapshot to be used. It uses a POM file for module metadata. I'm sure everyone here is familiar with the POM. It's kind of funny because it's actually a build file as well as a module descriptor file. So it doesn't have one purpose. It's hard to find out exactly what's meant to be what's part of a published POM as opposed to the build file POM. There's not really a clear separation between those things. But it works all right. You know, it allows us to define. It allows you to define dependencies in various scopes. One thing it doesn't do is it doesn't list the artifacts that are a part of a module. So effectively, the POM packaging is what we use to sort of work out what artifact will be there. And there's usually only one artifact per module. If you have more, you're pretty much stuck with kind of going, okay, I know this artifact's going to be there, and I'm going to ask for something with this classifier. There's no way for a POM to say, hey, by the way, I've got a sources jar and I've got a Java Docker zip, and they're called this. It's kind of conventions and an implied knowledge in your build script that does that. So, and I'll compare that to the Ivy file format in a sec. And so Maven repositories have a special handling of snapshot versions. So they're considered considered something that changes over time. So the same version, different artifacts over time. And quickly, so that's a Maven repository configuration. Nothing too exciting there. You can define credentials for HTTP authentication. You can define the main search path for everything where all the POM files will be. And if you have some artifacts that are not in your regular repository but somewhere else, you can add that into. One thing that's interesting is I've got up here I'm using Maven as the keyword. There is actually a repository type called Maven repo. It's a little bit historic, and this is an example where Ivy APIs have leaked into the Gradle API. If you use a Maven repo and you actually get the return value, it is an Ivy dependency resolver, which lets you tweak it any way you like. But it also means that we can't change it so it is no longer that, because other people will be breaking people's code. Right, so that was Maven repository. Next thing is the Ivy repository. So how does it differ from Maven? It's got a flexible layout, so you can pretty much configure the layouts any way you like. You can configure them in ways that they don't work. You can leave the revision out completely, and Gradle can't work out what to do. But it's a bit too flexible in some ways. Just uses HTTP direct. Yep.
So for the Maven thing, can you use the settings.xml that Maven typically uses for credentials and URLs? So could Gradle use that? Or?
No, it does not.
What?
No. So because the publishing support does use the settings.xml, because publishing is still using Maven ant tasks under the covers, but the resolution support doesn't use that. Yeah. So Ivy uses HTTP directory listings to get the versions. So basically, it's a bit unfortunate. Your whatever's serving up that has to serve a directory listing that's in an Apache 2, like an Apache 2 compatible format, so that we can then parse the returned HTML and work out what the things are, what values are in there, what artifacts are in there, or a file system listing, which is pretty sensible. Ivy XML metadata format allows us to have. It's a much more flexible, much more powerful than a POM. So a POM is just, here's the thing, here's a set of dependencies, and there's going to be an artifact. Ivy says, here's my module, here's my configuration. So here's my API, and here's my implementation. My API includes my API jar and these particular dependencies. my implementation includes my API jar, my implementation jar, and a bigger set of dependencies. So it's a lot more powerful format. You can define a lot more with an Ivy XML file. Allows you to choose whether you want to replace the dots with slashes in your group IDs, but it doesn't have any special handling of snapshot versions. So to Ivy, and when Gradle's using Ivy, it's just a snapshot is just another version. It's nothing. There's nothing special about it, and that does cause people some confusion at times that they don't get the same behavior when they're using Ivy and a snapshot pattern. And again, just an example of what it looks like. So here I've got credentials, a base URL, and here you can define. We're defining a pattern layout. So we're saying all the Ivy files are in this particular pattern, all the artifact files are in this particular pattern. This stuff's all really well documented in the user guide. I don't want to try to explain this because I want to get into the deeper stuff soon. So, and I'm saying it's M2 compatible means that we are going to, this little bit here is going to be that organization, any dots in there will get replaced with slashes. So it'll look more like a Maven repository. And finally, if we're using, if you don't have a Maven or an Ivy repository, you can use a native Ivy dependency resolver to access. So for the cases that I mentioned before, where you're resolving by SFTP, or you have some sort of custom resolution logic that doesn't fit into a normal a normal repository format, you can basically just configure a native Ivy resolver, add it as a repository, and Gradle will wrap that dependency resolver and use it as and present it to Gradle as a repository. So it's this is kind of the stuff that we would love. If you're needing to do this, we'd like to know, so we need to know the use cases that we can start to replace and eventually deprecate this support altogether. All right, so plans for the future in repository land. So it's kind of like I've showed you, there's an Ivy and there's a Maven repository format, but it's pretty inflexible. Like it's pretty much, you get one or the other, you don't get, and if you need anything else, you've got to code up your own Ivy dependency resolver. What we'd love to do is start to look at a way to compose. I want to use Ivy XML format. I want to use Maven metadata to list my versions. I'd like to use an FTP transport, and I'd like snapshots to be considered changing automatically. So sort of composing these things up. So this is where we see Gradle in the future. A repository will just be a composition of these sort of bits and pieces, and we'd like to allow you to implement your own transport, let's say, without having to implement the rest of the stuff that goes around it. So, or your own, say, version listing protocol. So, these are the ideas we have in the future. Another thing that'd be kind of cool to do would be have programmatic mapping instead of this sort of pattern-based mapping. So, like, because we're using Groovy, we can just say, give us a closure that we'll give you an artifact, you give us a URL. Like, why do we have to have this sort of M2 compatible flag, here's a pattern. It's like, you can tell us where it is. There's no, like, we got code here. We don't have to do everything in XML. So it's one of the things would be kind of cool to do. And a much better way to specify which modules are changing, because currently it's snapshot, nothing, or you have to define everything in your build. You have to explicitly specify dependencies as changing. So we'd like to be able to do that too. All right, so that's the kind of the boring stuff, I guess. The stuff that there's sort of this high level information. I want to do a lot more coding now for the next few bits of talk. I want to do some demonstrations and stuff of how resolving works and when it does and when it doesn't. So, does anyone have any questions before I go on? Anything?
About the layout, you plan to extend, have more layouts or drop it?
I'd probably prefer to go with that sort of programmatic. It's an infinitely flexible layout. If you say, we'll give you the artifact ID, you give us the URL, then you can define any sort of layouts you like. It's because I mean, is there an example that you'd like to see in the layout?
Just branching or feature.
Yeah.
Or isolation.
Yeah, a lot of those things aren't part of the Gradle model, so it's like branch is not part of the module. It's not part of the actual DSL, so we'd have to add that to our actual model as well before you'd have that information.
So when you say artifact ID plus group ID, do you mean also version number as part of that?
Yeah, absolutely.
Okay.
Sorry, I'm talking in a high level. A module ID is a group artifact ID version, and an artifact ID is a module ID plus something to define the artifact itself.
So if you want to have a way to change the actual figuring out what version you use, that's a different plugin point than this one we're talking about.
Yes, that's right. Yeah.
Cool.
That's. Yeah. All right. So this is kind of basically what goes on when we try to do resolution, and this is kind of the nuts and bolts of what I'd like to try to get us to understand today. Some of this stuff is logical steps, doesn't necessarily happen in a way that you'd be able to tell that these steps are separate in code or in Gradle, but this is kind of logically what goes on every time we do resolution. So we take your dependency that you've declared in your build file, and the first thing we do is we build a module version, what we call a module version selector out of that. So a selector is like a query. It's like saying, okay, I want to. This is kind of what I want. You know, we have the version part. We call them dynamic versions and static versions. So I've represented a dynamic version there, which is it's a version range. It allows multiple values to be returned. A static version is always going to return a single. It's like a query that will always return one row. So from that, we then ask, what are the matching versions for this selector? What things could meet this selection criteria? And we get back a list of actual module version identifiers there. We basically, next step is to actually select which one's the best one to use. Once we've selected the best one to use, we can resolve the actual metadata for that version. And obviously the dependencies from that feed back in, go back through the chain because that's transitive. And we also have the artifacts on there where we can actually resolve the actual artifacts that we need to get. This is kind of the process, and it's important to understand this for a couple of reasons. One is caching takes place at different levels in this chain, and the other thing is some of the control points that you have, some of the places where you can go in and manipulate, they actually fall into different places in this chain as well. And there are some that we don't yet provide hooks for, but we'd like to in the future. So the idea is that I'll go through it a bit later on. Yeah, some of them don't yet have places you can control it, but understanding this will help for you. It helps me to explain what we're trying to achieve as well. Okay, so I'm going to go through a couple of examples now just to show what's going on with when we're doing resolution. So I've got so I've done up a little demo project. It's the first thing I'm going to do is publish some jars to a file system to a repository, and I'm going to serve them up. I've got a little dummy HTTP server here that can serve them up. So I'm using the new, I don't know if anyone's interested, but I'm using the new publishing support, so the new publishing plugins. I'm doing a talk on that stuff tomorrow at about 4:30ish. So if you're interested in how the new publishing support works, come on to that. So I've published that up, and I'm going to use Gradle with a bit of Jetty to serve those up so that they're available via HTTP. And what I've got here now is a really simple Gradle build file. Got configurations defined, a single configuration defined. I've got a single Ivy repository defined, one dependency, which is going to be served up by that HTTP repository I just set up, and a resolve task. And the resolve task is pretty much printing out the names of the jars, but it forces dependency resolution is all we really care about right now. So I'm just going to try to resolve. And quickly, if you want to have a look, here's the repository I just generated. If you can look over on the right-hand side, there's two versions of that. There's only one module. There's two versions of the module there in the Ivy repository, and two versions in the Maven repository. So you'll see there's a 1.2 in the Ivy repository and a 1.1 in the Maven, and 1.0 is in both of those. So first thing I'm going to do, I'm just going to try to resolve 1.0 from the Ivy repository. So just I'm using GR because I type Gradle so many times a day. I shortened it. So here we go. So we've just resolved So this over on the right hand side of the screen, you can see the actual HTTP request that happened. We went to the Ivy XML file. We found it. We went to the jar file, we found it. It's pretty straightforward, nothing too interesting there. So one thing that Gradle does is it definitely honours the repository order. So if we put the Maven repository, if we put the Maven repository above the Ivy repository in the list and we resolve again, we'll see that you'll get the same. You'll get this time we're getting a Maven version of the artifact instead of the Gradle version, instead of the Ivy version of the artifact. So repository order is important in our build file. Just put that one back there. So one other thing. So then we can have a look at what's going on when we if we try to resolve 1.1. So 1.1 is only in the Maven repository. It's not in the Ivy one. And just clear that out and try resolving again. So we're making HTTP requests where it's going to make an HTTP request first to the Ivy repository, tries to get the Ivy XML file, it's not there, tries to get the jar, which I'll talk about in a sec, even though you might think it shouldn't. That this is part of the way Ivy works. It tries to get the jar, doesn't find it there, so then it goes and finds the POM. That's successful, looks up the POM, goes, okay, cool, I'll grab the jar, and it's done the resolution.
Is there any way to get it to stop after the first one? Like, because we have multiple repositories, and it's kind of a way of controlling which one's stable. And if it's not found in the one, we don't want to continue to the next one. Not really. I don't quite understand your use case there. It's kind of a weird
Like you can programmatically remove the repositories from the list. I can't think of. Do you need all those repositories available for certain dependencies you want to?
It has to do with the life cycle of the build. So as it progresses in the build, we only want it to resolve from certain repositories because of the stable versions of the jars. So once it gets far enough along in the process, you won't want to go to the changing jars to resolve those.
Right.
So it's kind of a way of, as it gets farther along, we don't.
Yeah, I mean, normally I would suggest not having those repositories available during that resolution step, which is not too hard to do. You can manipulate the set of repositories that are available. So there's no way, we don't currently have a way to say for this dependency only resolve from these repositories. That's not part of the API. Where are we up to? So yeah, finally if we try to ask for a dependency that just doesn't exist, so I'm going to just use 1.x, we'll get a failure. You guys have all done this before. I was showing you a bit of it for completeness. So we've got it's not found in any of those repositories. It looked both in Ivy and in Maven, didn't find it. Looked for both the POM and for the Ivy XML and the jar, the POM and the jar. So that works. And then finally, I want to show you why it's asking for that jar file. So I'll go back to the 1.0 case. And what I'm going to do is I'm going to remove Maven from the set of repositories. So we're just looking at Ivy, and we're just looking for 1.0. I'm going to remove all of the metadata files that have been published. So it's only going to be the jar file there, nothing else. So I've removed that there. I'm going to clean the cache because otherwise it's going to use cached versions when I didn't want it to. So let's just try resolving now and clean this on this side too. And so you'll see what's going on. What's happened here is actually we've gone up and we've gone, try to get the Ivy file, no, it's not there. I do a head request for the jar file, because I mean, I don't normally want to use it, but if that's my last chance, I might use it. It existed, so then Gradle goes, okay, cool, I'll use that. I'll just pretend there's a module there. I'll just assume it has no dependencies, assume it's the only artifact. So effectively making a metadata for this, which is no dependencies, one artifact, it is a jar, that's all. It's unfortunate because this is a magic, it really ties into Java. This doesn't work. There's nothing equivalent for an RPM or for C++ development. It's something we've inherited from Ivy, so it might be behavior that we remove in the future, but it explains why you might be seeing extra head requests for jar files when they're slowing you down, or you don't understand why there's head requests. That's usually why it's happening. So All right, one other thing. So if I add, what's nice about it is that Gradle will prefer the repository with metadata than the one without. So here I'm adding Maven back into the set of repositories. So we had just Ivy, it only has a jar file, but Maven has both the POM and the jar. Gradle's going to prefer that. So it's going to first go and look in Ivy, it's going to find it, but it's going to go, let's check Maven because it might have a better version. We trust it more. And sure enough, it'll go in and find the one from Maven and use that instead. So it actually, I didn't clean the cache, so it didn't have to go back and look in Ivy again, but it's preferring the Maven version. So it'll always prefer something with metadata than something without. So that's kind of, and one more thing we'll do, which is the dynamic versions. So I discussed that before, what a dynamic version is. It's a version range, something that can return more than one module version. And I'm just going to clean the cache again. We'll have a look at what happens when we resolve that. Rightio, so what's going on here is we've got 5 requests happen. We had a clean cache. So the first one up there, you can see that we're getting an actual directory listing from the Ivy repository. Directory listing is telling us, yep, there's a 1.0 and a 1.2. I think, if you don't remember, that's what it was in the Ivy repository. The best one of those is 1.2, so we'll get that just to get the metadata for it. Then we've got our best guess for the Ivy repository. Do the same thing for Maven, except that instead of using a directory listing, we're using the Maven metadata file, and we're parsing the output of that to get a listing of a listing. And we found that 1.1 is the best one to use. So those first 4 lines are kind of getting to the point of which one is the best version to use. Finally, we know we can do the very final line and say, get the jar file from Ivy. So we've only gotten the jar file for the best version that we wanted to use. So yeah, so just going over that. Always checks for metadata file. If there's no metadata file, searches for a jar file. Always searches the repositories in the order that they're defined. So if you switch the order around, it's honoured. Fails if there's not found anywhere. For dynamics versions, you use a directory listing in an Ivy repository, uses Maven metadata in a Maven repository, and it searches every repository and finds the newest one. So pretty straightforward stuff. Dependency artifacts. Let's see how the time's going. So we only request an artifact from the same repository we found the module. So we're not going to go, if we find the module in Ivy, we're not going to go and look in the Maven repository for an artifact. We're only going to look in the same repository. If you want to add additional artifact URLs, you can, but there's no way to say, oh, actually use the third repository to find the artifact where you loaded the module from the first one. Gradle treats those as independent stores of data. They don't interact. So with Maven POM, it doesn't. Oh man, what's that? With the Maven POM, it doesn't define the artifacts that are available. So we just assume there's one per module, and you can use classifier to access additional artifacts. So you need to define another dependency with a different classifier in order to get an extra artifact out of the Maven repository. Whereas with Ivy, you can say which configuration you want to load, and once you've said which configuration you want to load, it will load all the artifacts that were defined for that configuration. And Gradle defaults to using the default configuration always for when loading. So it's if you're wondering what's going on, why we always have a default configuration in all of our published modules, that's why. All right, is there any questions before I go on to caching stuff? Crystal clear. Okay, cool. So caching. So we've done a lot of work on caching in Gradle. We've tried to, we spent a lot of time making it fast, making it efficient. There's more stuff that can be done, but I'll talk about the good stuff first. So first thing that's important to be aware when we're doing caching is that caching is repository aware. So what that means is that if you found a module X in this particular repository once, let's say you loaded JUnit from Maven Central at one point, and then you tried to find another module and you loaded it from another, and it wasn't in Maven Central, so you added a special repository for that, and you found that as well. Gradle's only going to use the the JUnit that came from Maven Central. Like if you have to have Maven Central declared for Gradle to use the cached version from there, and you've got to have the other repository defined to use its cached version. So you won't. The benefit to this is build reproducibility, because a classic use case where something works on my machine because the jar file was actually in my cache, but wasn't actually included in any of the repositories I had. So Gradle won't have that problem. You basically can say, we check all of the repository lists, and then we make sure that the things that you get out of the cache are only the things that are available from those repositories. We have we store a pretty rich metadata about the things, about the downloads we've made. So we don't just store the artifacts. We store when we go to a repository and we ask and it's not there, we store that information. When we go to a repository and we do find something, we don't just keep the artifact. We keep the E tag that might have been sent down in the header with the request. We keep the checksum of the artifact. We keep the content length and the date that was reported by the web server when we downloaded it. And these things are all really important for the third thing in the list here, which is the local artifact reuse. So this is the way that we maintain separate caches for each repository without forcing you to download again for every repository. So we can say, well, actually, that's the same artifact because it has the same SHA1 key. Or we can say, that's the same artifact because it comes from exactly the same URL and it has the same modification date and content length. So we use head requests a lot, and we use SHA1 hash requests in order to avoid you having to download the actual jar file every time. And the goal is that you only have to download a jar file once, but we still maintain this rich knowledge of where you could have downloaded it from if you needed to, so that we don't have this problem where build works for you and doesn't work for somebody else. We've worked hard on making the cache concurrent read-write safe. So you can run multiple Gradle builds and share the same cache. It's not a problem. So on your Jenkins server, you don't need a separate cache, a separate Gradle home for every Jenkins job. On your local workstation, you don't need it either. So, and what the cache has provided is pretty good offline support. It works well for disconnected development. So it's one of our really heavily requested features early on, and it's worked pretty well. So I'll do a couple of demos of actual caching and what's going on there too. So going back to my little demo here, I'll just republish because I deleted that module metadata. And that might just confuse things. So, and we're going to use a different demo file. So this is my demo file. So you see, once again, I have an Ivy and a Maven repository declared. I've got a single dependency, and I've got a nice resolve task. This time it's actually going to print out the number of bytes in the file resolved, just so we can see when it's different or not. So just going up into that one. So we're still serving things up here. I'm just going to resolve. What number are we up to? We're going to resolve version 1. See what happens. Exactly what happened before, but we're going to do it one more time and just prove that caching is working for us. So there should no resolution happen. So there's no HTTP requests that happen there. So I guess the question is, how long is it going to stay like that? Like, when will it look again? And the answer is never. The answer is Gradle basically assumes that if you've got published metadata, it's constant. Gradle doesn't need to refresh that metadata. That if you think that your module with your identifier doesn't produce constant binaries, constant metadata, if your identifier doesn't relate to a constant module, then you need to tell Gradle that it's changing. Gradle will assume it's not changing otherwise. So one thing that Gradle does here is it still continues to honour this repository ordering. So just because it's been cached doesn't mean that it's going to use the cached version over a repository higher in the list. Yep.
So with having to specify that something's changing with a Maven dependency, you would just get a snapshot suffix. How do you specify that with Ivy?
I'll get to that in a second. Yeah,
okay.
for sure. Yeah. So just to recap, yeah. So I just moved the Maven repository to ahead of the Ivy repository. So it's being cached in the Ivy repository. It's not in the Maven repository. And then this should just show that we're not going to use the one that's cached. We're going to use the one that's first in the list. So that makes sure that your build is reproducible. That it doesn't have some sort of weird behavior that's caused by something being cached earlier. Gradle, we try really hard to be consistent. Caching have no effect on the actual behavior. Except for speeding things up, of course. Otherwise, it would be kind of not much point. Yeah, so then we'll have a look at the resolving 1.1. So, as I said before, 1.1 only exists in the Maven repository. I'm going to put that one second. So basically, we're going to try to resolve it from Ivy first, and then try to resolve it from Maven after that. Doesn't actually, in these cases, it doesn't actually matter that this one's an Ivy and one's a Maven repository. I should clarify that. They're just two repositories. One's 1 and one's 2. There's a few times when they make a difference, but a lot of the time they don't. So I'm just going to resolve the version 1.1 from there and have a look at what requests we get. And you'll see once again we've got not found in the Ivy repository and we found it in the Maven repository. If we do that resolve straight away again, you'll see the benefits of Gradle remembering where things are missing as well as where things are found. So Gradle remembers, no, it's not in that Ivy repository, I'm not going to go back looking in there. But I know it's in the Maven repository. So it's both of those two pieces of information are critical to avoid having to make any HTTP requests there.
I'm sorry, is that cached forever, the knowledge that something is not in a repo?
That is cached forever now, yes.
Because that seems like that could change, right? If published with every other repo.
Yeah, it's cached forever, unless the only time I'll show you in a sec a case where we ignore our assumptions and go back and check.
Okay.
Yeah. So is there another question there? Same question? Okay. And maybe that's not the best. Maybe that's not the best scenario. But we don't have a cached missing modules for flag in our DSL yet.
What if some other system goes ahead and adds that in to the repository? So it's not in the cache, but so it automatically will always go.
It won't look there unless it doesn't find it anywhere else. So right. I'll show you that right now actually. So if I change this to be 1.x again, you know, the sample where it wasn't found in either repository. If we have a look at that, it's going to try to find it. It's going to try to find 1.x in both repositories. It's not going to find it anywhere. If you try again, it's not going to go, oh, I know it's not anywhere and I'm not looking anywhere. Before it fails to find it at all, Gradle will go and look again. Yeah. So it's a tricky balance to find. You know, how do we tell Gradle that something might reappear sometime in the future? Probably like a 24-hour period might have been better than a forever period, but I'm pretty sure it's not. I'd have to check actually but I know at one point it was using the dynamic version cache timeout, and I think when we implemented this feature that we always go back and check if you can't find it anywhere, I think we removed that timeout, so it's now on an infinite timeout. But I have to check that. Yeah, cool. And then the other thing is just looking at dynamic version caching. So if we do that again, I'm going to clear the cache on this, just so we have something nice to work with. We're resolving 1.+. So that's the dynamic version we did before. Basically, we've gotten it out. We've got the listing from Ivy. We've got the listing from Maven. We chose 1.2, exactly what we saw before. But now we've got we've cached all that information. So there's an extra piece of information cached here, which is, if you remember the blue diagram I had earlier, it basically, we're caching, I might even flick back to it, hang on a second. It's not too far. So we're caching caching here, so basically we're caching the metadata for a selected version, and we're also caching from here to here. So we're caching from, given a selector, give me the list of matching versions. So when we're using a static version, there's not really any, the caching is kind of transparent down to there because there is only one choice. But in this case, we're caching both the lookup between the module selector to a list of versions. Logically, that's what we're doing. And then we're also caching the lookup between, once we've got a version, getting the metadata out for it.
And when does it refresh the list of versions that match?
Sorry, I was going to show that. It's a very good question. So basically, we're caching the mapping of module version selected and module version. By default, it checks every 24 hours.
Got it.
So I was going to demo that. Maybe I won't worry too much. So we, I might as well show that how that works. I had a demo set up for that. So we've got let's say we want to publish a new version. We've resolved this. We know it's there. We've got 1.2. We're getting 1.2 every time. There's two things we need to do to effectively make Gradle detect a new version. First thing we need to do is publish it. So I'm going to add that to my publishing thing. So I've got a version 1.3 that I'm going to publish to the Ivy repository here. So I'm going to do that here. So that'll publish that up and start serving it up again. The other thing we need to do is we need to go into our build file. That's the earlier one. And tell it how long we want to cache dynamic versions for. So you have to believe me, if we stayed here for 24 hours, if I could talk to you for that long, eventually we'd see those things recover. But I'm sure we've got better things to do. So what I'll do is I'll change this to say, it's actually 20 seconds we want to cache dynamic versions for. Now those versions should be more than 20 seconds old already. So when I resolve again, you see we've done all the requests again. And this time we found 1.3. So sorry, I might have been a little quick on that here. So what I did here is I used this cache dynamics versions for method on the resolution strategy, which basically says hold that bit of the bit of mapping between this module version selector to the module version. Only keep that for 20 seconds. It's stale after 20 seconds. So, yeah.
Is there any way to configure that? Never mind even just a numeric value, but just never trust the cache.
You can set it to 0 seconds. You can set it to 0 seconds. Yeah. Which is the same. Yeah. There's no nice keyword for that. Like, there's no don't cache dynamic versions, but 0 seconds is effectively the same thing. Yeah. Right, so back here, so I want to talk a little bit. So I've shown you the cache in action, but I want to just talk to you a little bit about the actual physical files that are in the cache. This is kind of getting about as low level as we can go. There are three primary parts, in a Gradle cache. There's a file store. So the file store is storing everything that was ever downloaded. There's some binary metadata cache files, which are kind of maps where we can look up like artifact attributes, and they mostly point to files within the file store. And then we have an in-memory module cache, which is really it's a within build type of thing as opposed to a cross-build thing, so it's not so important. The file store, so we can quickly have a look at actually what the file store looks like. So I've been using a local Gradle home in each of these cases, so I'm not using a shared Gradle home. So within that caching directory, we can have a look at what the actual cache looks like. So that's that artifacts 25 is the cache, and there's the file store. So what have we got in our file store? We've got a com.GradleSummit.dr. So it looks a lot like a Maven repo. Yeah.
Are this artifacts 25, is that from a version number? Like the new version of Gradle comes out, the new form of the cache?
Anytime the cache, anything in the cache format changes, we bump that version. It's a little bit unfortunate that I think I said that on the slide. It's a little bit unfortunate that the file store has been lumped with the binary files, because anytime we change our implementation classes, our binary storage format changes. The file store hasn't actually changed in layout since 1.0. So if we'd had a little bit more foresight and we put it as a sibling instead of as a child of that artifacts 25, it would probably still be on file store 1. So it's versioned independently of the Gradle version, but it's just based on how many times that layout has changed. So often between Gradle versions, it'll bump from artifacts 18 to artifacts 25, because every time we produce a new nightly release that has a change, we have to bump that version number. So it allows us to keep evolving our cache layout and have it continue to work. And we use something, artifact reuse, which I'll talk about in a sec, to reduce the need for you to re-download things just because we've bumped that version number. So this is the file store part. So this is the part that it's pretty transparent. It does make sense. You can sort of understand what's going on here. Yeah.
So, just curious, if I publish it to the same gap coordinates, what will be the caching strategy? So like, I publish it to say GAV, and tomorrow again I publish it to the same GAV. Would cache reflect, and I published it by mistake at the same GAV?
When you publish, so the Gradle cache won't detect that change unless it knows it's changing. So I'll talk about changing modules in a sec, which are where you can tell Gradle this same GAV has content that will change over time. Okay. That's what we call a changing module. So yeah, but right now we haven't dealt with any of those. So we've only dealt with modules that are, once we have the identifier, we assume that identifier, the metadata for that identifier is just constant over time. So this is the, if we quickly look at, oh, that's not nice. Let's just expand this out. So we can have a look at what's actually in that file. So you'll see we've downloaded a POM for 1.1. We've downloaded an IV and a jar for 1.2, and we've downloaded an IV and a jar file for 1.3. So the format's very similar to a Maven repository format, except that we've got this, we've got the type, and we've got an SHA1, a SHA1 key in the directory structure. So what it means is we can store two artifacts with the same ID in our cache, and so that's probably the most understandable part of the most transparent part of the cache from a user point of view. We don't support this as a format, but it can be interesting to understand what's going on. You can go and have a look at what's in there and work out why. We have these so the file store contains every file that's ever been downloaded by Gradle, stored in that format with the artifact ID and the SHA1 in the path. That allows multiple artifacts with the same identifier, and that's what I was saying. That layout format has actually stayed constant since Gradle 1.0. So although it's actually been under different artifacts dash something, the actual format layout of that directory has stayed constant. So the other files we have in there are the binary caches. So we have a dynamic revisions.bin, which is actually that cache that maps a module version selector to a module version. Then we have a module metadata.bin, which actually maps a module version ID to the set of points to a module to an actual module metadata for that file. And then we have these artifact maps, which are actually used for both looking up the exact artifact and for the artifact that URL keeps track of the e-tag, the content length, the date that we downloaded from a particular URL. So it helps us to do that artifact reuse, which I'm going to talk about in a second.
What's an e-tag?
So an e-tag is a header that gets sent down with a HTTP response that it's server dependent, but it's constant for a particular resource. So it's basically the server saying, you can use that in an if modified sense in HTTP. You can say if the e-tag has changed, this is the e-tag I got last time, so only give it to me if it's changed since then. And so it's like a SHA-1 hash, but it's more, the server can implement their algorithm for generating that any way they like. We can use it in the same way, and so we use a head request to get that, to compare it to our previous head request. All right, so changing modules, which people have been asking about. Maybe I should have got to it sooner. So a changing module, by Gradle's definition, is a module where the module content can change with the same identifier. So it kind of breaks that assumption that we make that a module, that an identifier maps to a single module. We don't like them very much, but they're a reality in the world. Snapshots are an example where we love to move them into sort of more of a dynamic version thing. They actually have a version that we could use. It'd be kind of cool if they were actually more uniquely identified, as opposed to if you're losing information when you say it's just that's the identifier and we don't actually know what's under the covers there.
So in a system where you were, say, having 250 module type objects, each of which are building 2 or 3 jars each, and it's in a development mode, so you're constantly, would you be expecting to be constantly upload every time you do a build, have a new version number and pop that up into the repository?
I mean, timestamp would work pretty well in a version.
As a version number,
yeah.
But yeah, so
yeah. It's just, we haven't come up with a great solution to this yet, but it doesn't feel right that we're losing information, that we have these identifiers that don't have a meaning, that don't say exactly what this is. So
yeah, the only problem I can see is if you're doing 4 or 5 or 6, 7, 10 builds a day, your repository is going to become bloated with all of these. Yeah, so
that's a different problem. I mean, that already happens with changing modules.
Right.
Because or in our cache, maybe not in the repositories themselves, but in our cache, because we store them forever based on the SHA-1 hash.
Okay.
When you use changing modules, your cache continues to grow anyway.
Is there a way to clear it?
No. So that's one of the downsides I'm going to talk about in a sec. So.
Okay.
So Daz, you're saying that if I set it up for changing, and I go get a new version of the same identifier, you actually keep in the repository another version?
In the cache.
In the cache?
If it's different. If it's the same, we don't keep it different. Keep it. We keep every unique version that we download, we keep.
Okay.
Yeah. So, and I was just having a discussion with someone over lunch about how painful it is to try to manage a rapid development cycle with lots of changing modules. It's not something we're not aware of. It's just, and I guess in trying to explain that the file store is a fairly, although it's not a supported layout, it's a fairly constant, fairly transparent layout. There are ways for you guys to manage you can delete stuff from there and it will still, and the Gradle cache will continue to work. So this is not it's not a supported feature. What we really want is a supported way for Gradle to say, clean my cache, get rid of all the old stuff, whatever. But in the meantime, that file store is actually a fairly transparent mechanism. So if you look at your cache, 99% of the volume will be in the file store, and there's no reason you can't write a shell script to go in and say, remove everything with a snapshot in the directory name, and then it'll delete all the snapshots, and things will continue to work. So.
Or it might even make sense to have a different configuration that I have. These modules are going to be changing a lot, and I can have a task that says, go clean these out of cache, and then go do my...
You could, yeah. Ideally, you wouldn't need to, I guess is what I'm saying. Ideally, Gradle would do this.
If you're going to keep a copy of each one of them, then I probably want to go clean them out.
Yeah, sorry, what I'm saying is ideally, Gradle will do this for you. Gradle, because it is a cache. It doesn't have, it's an optimization. A cache is always an optimization. It's not a store. It's not a repository. And I think people from Mavenland have come to think of a cache and a repository as being the same thing. But Gradle's cache is strictly a cache. We should be able to flush it and not have any noticeable impact on behavior. Unfortunately, at the moment, we don't have a way for you to flush it except for by, officially delete the whole cache, change your Gradle home. But I guess I'm saying it is quite possible to manipulate these files yourself by removing the ones you want to and not the other ones.
So you're saying your future path would be
absolutely
to be able to go clean out all those duplicates and just keep the last one that I wanted?
The future path is we know what things are used by your build. So we can have a look at what builds you're running, and we can say, actually, your builds only ever use the newest version of these changing modules. They don't use any of those old ones. So let's just get rid of them. We don't even have to go on timestamp. We have a rich domain model that lets us know how things got into your cache. So there's stuff that we know with the current builds you're running, these things will never get used. There's no reason why we can't get rid of those. So right now we just don't. So contributions are welcome. Cool. So. Changing modules. So Gradle, you need to tell Gradle when the module's changing. So there's two ways to tell it. If it's a Maven repository, you put snapshot in the name, which is the Maven pattern we've adopted. If it's not a Maven repository, or even if it is, you can always say on a dependency, this module is changing. And that tells Gradle, right, I can't trust my copy. It could be different. By default, we cache things. The only difference between a changing module and a real module, a non-changing module, is caching. There's no difference in behavior. Gradle doesn't treat them differently, except for in the way it caches them. So it's important to understand changing modules are not special in any way except for the fact that they're cached for 24 hours and then refreshed. And that you can change the timeout by saying how long to cache changing modules for.
So is there an Ivy repo way of saying everything's changing? Something like that?
No.
Okay.
So there's no pattern on a Ivy repository that you can say things like this change. You can do it programmatically by getting every dependency and setting the changing flag on it, but you can't. There's no pattern you can set. And that was what I was talking about before about wanting to be able to compose different repositories. So basically say, I want to use the Maven snapshot model, and it's quite a common one. Like, it's become a de facto standard that snapshot means changing, but if you're using an Ivy repository, it doesn't. So we'd love to be able to add that in.
So if I define changing true on a dependency, does that also apply to all the transitive dependencies?
No, it doesn't. No. So you'd have to do it, but it's not too much Groovy to do that yourself too. So, yeah.
So let's say I'm going on a plane, I'm trying to do some development work, I know I can't connect.
Mm-hmm.
I know that it's going to try to connect, so it's going to time out for all of these things. Is there a way to just when I do my build, just to say, use
offline?
the cache?
That's offline.
Just dash offline?
Yeah. So, and I'll get to that in a sec. I think I'm going to run out of time to actually, I was going to demo this, but I think the questions are probably more valuable, so I'll just keep going on. So more questions is fine. Basically, it's exactly the same as cache dynamic versions for, cache changing modules for. You can set it to 0 seconds, you can set it to 2 minutes. We actually adopted the Maven default, which is 24 hours. So that's what Maven does with snapshots by default as well. So,
is there a way to hook into the cache resolution here to support maybe pulling and rebuilding from source at this stage?
It's not, no, and it won't be something to do with the cache. That's more like a dependency resolution problem, where what we love for our long-term plans are for, I don't know if we have plans for inter-project dependencies to be not much different from module dependencies. So, I'm depending on that thing. That could be a locally built project. It could be something from Maven Central. It could be something built from another developer's machine and uploaded onto shared with the rest of the team. So the idea is that we take away some of this distinction between locally built inter-project dependencies and remotely downloaded dependencies. And you'll probably hear a bit in the next couple of days about the decoupled project model, which we're moving towards. So basically, right now, inter-project dependencies allow you to do anything. You can reach in and touch any little tiny piece of the other project, and that makes it fundamentally different from a external module dependency, which is just a get this jar. So the idea is that we want to clarify these dependencies and then make them more similar over time. Does that answer your question?
There is no closure that can be called on the dependency to set the flag changing true based on some dynamic logic.
Not directly. Like there's not in a declarative way. There's a way you can do it with Groovy by iterating through every dependency, yes, and setting changing as true.
Because there is the closure for the selected version for impacting the way the version is selected or whatever.
Like it's dynamically, yeah.
The dependency resolve rules you're talking about?
Yeah. You cannot inject changes.
Yeah, you probably can do it there. I hadn't actually thought about that. It's probably... No, you can only affect the module version selector at that point. You can't. So you can only affect the identifier, not the changing attribute. No. So... Oof. This is obviously a really important topic. Changing modules, okay.
It is.
Yeah.
So what about publishing? Let's say I want to publish a module to Ivy through an event. How does that affect the local cache?
It doesn't at all.
It does not.
No. There's no, publishing has no impact on, so unlike in Maven where when you I think it's upload, you often install at the same time. Gradle doesn't do that. So so Gradle doesn't put a copy into the cache when you publish at the moment.
Okay, so do that you have to reinstall that.
If you want it to be in your cache, yeah.
Okay, so in ID's context, the cache is basically local copy of the concept. I'm getting the impression that Gradle's cache is more of an optimization. Is that correct?
I'd say that in Ivy's case, it is also an optimization. I'd say that in Maven, it's not. In Maven, it's definitely a repository, and they make no. That's actually what it is, and it's that shift that a lot of people have trouble with, is that we don't see it as being a repository. It's not a public format. We don't say this is how it's laid out and we're never going to change it. It is strictly an optimization. I mean, the reason it's important to understand it is for things like we haven't yet implemented automatic cache cleanup. So if you want to clean your cache, it's important to understand what the current layout, and I say it hasn't changed since 1.0, so it sort of allows you to feel fairly comfortable that if you spend half an hour writing a script to do that, you're not going to have to do it every single time Gradle's released.
Any reason in particular you don't write it to the cache when you?
No, not really. No, there's not. It just hasn't. Yeah.
Well, no, there is an issue. You don't know which repository to cache it into.
Well, you know which repository you're writing to.
You should invalidate the cache. Just say that this is just, we know it's changed somewhere. At least as a compromise. Let the re-resolve find the new one, but we know that it's out of date, like for a fact.
For a changing module.
For somewhere, yeah. Maybe in one of our
Right.
repos, maybe.
A lot of time the publishing URL is not the same as the resolution URL anyway.
Yeah,
so
fair
you
enough.
will find a way to
That's
do
a
it.
good point.
All right, I better keep moving on because the next bit's kind of fun. What time does the session finish? 2:45. Okay, cool. So reducing artifact download. So this is it's another pretty important thing to understand, and it's how we get around. I talked about it before. It's how we can manage to have a per repository cache, but try to avoid having you download every single time you use a new repository. So when I say things are cached per repository, everything about the repository is included in that. The credentials you supply are important to the repository. The URL you supply is important to the repository. Any other attributes you set on a repository. It can be, as soon as you change anything about the repository, it means maybe it doesn't have exactly the same artifacts there. So that means we can't trust that our cache is up to date for that repository. So what we do to avoid downloading again from this, effectively I've set a tiny flag. I changed the password because I got it wrong the first time. Maybe not. Maybe it's a different user or something. To avoid re-downloading everything all over again, we use this artifact reuse. So, and the way it works is we first find all the candidate jar files, candidate artifacts that we think might be this one. So there's a lot of places we look. First thing we do is we go in the current cache with the same artifact ID. So anything that's got the same artifact ID, we go, there's a candidate. So we might have downloaded this from the same repository. We might have downloaded this junit.jar from a different repository. They're candidates. We grab those. We also look at a cache from a previous Gradle version. So when I saw that artifacts 25, if you had a previous Gradle version that had artifacts 12 in there, we'll look in there and go, oh, there's a jar file that might be a candidate as well. And then finally we go and look in your M2 repository. We go, okay, well that's got the same org/junit/junit 4.1. Yeah, that looks like the right one. Let's grab that too. So we've got a set of jar files that might be the one we want. We know that we have the SHA-1 hash for this. We calculate the SHA-1 hash, and then we can start using our cache information to work out whether it really is. So we'll do a head request to the but we never have actually downloaded from this exact repository with this exact URL before. So we're going to try it. We'll try, and we do a head, and it comes back and says, yeah, I've got it, and here's the E tag. And we'll go through and we'll look, see if we have an entry with that E tag. Yep, cool. It points to that artifact. We just use it. We're done. Often that's not the case. It's not. So the next thing we do is we look for a SHA-1, the artifact name with .SHA-1, which is a really standard publishing paradigm. And we use that SHA-1 hash. It's a small file, 128 bytes or something. Download that, compare that to all of the artifacts we've got as candidates, and if one of them matches, we reuse it. Oh, and the other thing we do is we do content length and date. So if we have the same URL, same content length, and same date stamp, we assume it's the same artifact as well. And so what this effectively does is it reduces your download to a bunch of verification, a bunch of really small HTTP requests and no big downloads of jars. And finally, yeah, if no candidates match at all, it downloads the actual file. So this is yeah, it's kind of cool. So it's the way we basically got around. So if you've never installed Gradle before and you've got Maven running, and it's got all the jars you want, you shouldn't have to download any new jars. It shouldn't take a long time to bootstrap your system for Gradle. I think I had a demo for this. Yes, I'll just do a bit of a demo on this. We haven't done that for a little bit.
Daz?
Yep.
Notice from the .m2 repository, is there a way to also tell it to look for other repositories, like for Grails or something like that?
No, there isn't. Yeah. It uses the settings.xml to find the local Maven repository, but it doesn't allow you to add that. Yep.
So after it does these calculations and it successfully decides, I think this is a pretty good match.
Yep.
Does it then put that in the cache?
It does.
Has to do it the next time?
Yeah, it copies that into the cache, into the file store, and it basically makes it keeps an entry that maps that module ID to that artifact, or that artifact ID to that actual artifact file. Yeah. So we'll go back and have a look at this again. So what are we going to do? Yeah. Oh no, I'm lost. So yeah, I'm gonna I'll just resolve once. We're gonna set this up as, because we didn't do the changing module demo that I was gonna do, and that caused me to screw up. Okay, we'll do it all in one go. So I'm gonna say 1.0 is a changing module. This is the way we do it. I'm going to say that we cache changing modules for 0 seconds. So we're going to get it every single time we're going to attempt to get this changing module. And let's just actually do that. So we expect to get we've got the regular thing. So it's a changing module. So if we run it again, we expect more HTTP requests. And you notice the second time through, we just did just head requests. There's no jar downloads that time. So we know straight away, same date time, same timestamp, same content length. It's the same thing. We don't have to do any more than a header there. What I'll do now is I'll actually republish with exactly the same content. So what that'll do is it'll change the timestamp on that, but it won't change the actual content length, or the SHA-1 hash. So when I resolve that again this time, you're going to see that the head request won't be enough. The head request doesn't tell us what we need to, but it does. But we do go. Oh, cool. We've got the lousy Ivy put a publication date in my change the actual Ivy XML file. So I'm just going to get rid of that one. Basically, I wanted to look at the Maven repository resolution only. So I'm going to just because. Okay, let me explain. What happened then is Ivy republished, but also changed the content of the Ivy XML file because it put a date stamp in there. It's kind of like when Java-C compiles and it puts a date stamp, so everything's changed, even though the source code hasn't actually changed. Or sorry, Visual C++ does that. So we'll resolve that again, and this time we're going to see. Yeah, so we got the POM. We didn't have that before in the cache. We headed the jar, and then what's going on? Do it one more time. That's what we wanted to see. Sorry, yeah. So the first time we did it, when it's exactly the same, it just does 2 head requests. When it's changed but not changed in content, we do a head. The head doesn't tell us that it's good enough, so we do a get on the SHA-1 tag hash, and we know that it's matched then. And then finally, if we actually publish with different content, so I'm just going to change one character there. Resolve again. Oh no, publish. Yeah, thank you. So we published, and I'll do one more resolve, this time with completely new content. And this time it did the same thing, but it went, oh, actually, the POM file hasn't changed. So we did a head on the POM, dates changed. We got the SHA-1 hash, and it's actually exactly the same because all we changed was the jar file. We didn't change the POM, so it doesn't need to re-download the POM. But for the jar, we did a head. It doesn't match. We did a SHA-1, doesn't match. So then we actually went and downloaded the actual jar. So we download when we need to, but we definitely don't when we don't. So cool. So a couple of utility things that are kind of nice to use. Refresh dependencies. So what this effectively does is it's a nice way when you're, like, let's say you forget to, I think you publish like I did just before, then you resolve, it's not there. So then you go and publish, then you resolve again, it's still not there, and it's because Gradle's remembering that it didn't find it last time. So what you can do is just use refresh dependencies. What it effectively does, it says every single module is changing, and cache timeouts are 0 seconds for both dynamic versions and changing modules. So it's really it's really a kind of a nice utility to recover from I screwed up my repository. Like I did things in the wrong order and things aren't right. I caution against using this as a part of your regular development process. If there are reasons why you need to use this as a part of your development process, we'd love to hear about it, because that's a use case that needs to be solved in a better way. Because it's a pretty brute force approach, right? Because it does for every single module, not just your changing modules. It'll say everything might have changed. It does use the artifact. It does that artifact reuse stuff. So it basically won't download unless it actually has changed. But still, it's not ideal, but it's a nice utility to use. And kind of the opposite to that is offline. So offline is a way to work disconnected. All we're really doing when we say offline is basically cache changing modules and dynamic versions for a long time, and then just prevent all remote repository access. So we just basically will fail if anything tries to do a remote access. So if we, so as long as everything's in your cache, doesn't matter whether it's changing module or a dynamic version, if you've got a version, something cached, it will just use that. So it's pretty nice for working on the plane and things like that. Right, so some issues or difficulties with the current implementation of caching. So the first thing is it's kind of a misunderstanding in some ways, but it's also it's something we do recognize that it's not a transparent repository. It doesn't like the M2 repository. We do reserve the right, I guess, to change it. It doesn't get changed very often, but we need to be able to optimize. We need to be able to keep making things better. So, but it does limit some use cases. Like, for example, people say, "Oh, how do I set up my IDE to point at those things if that hash key is going to change all the time?" And these are problems that we want to look at. We want to make it easier for you to get access to your, like a nice project local version of the cache that doesn't have the SHA-1 hashes necessarily in it, things like that, in order to set up a manual IDE task. There's no tooling currently to clean up stale versions. I think we've covered that already. It's obviously a bigger problem than, it's obviously a pretty big problem in people's world. So yeah, come and talk to us about this stuff too, because I know sometimes these priorities aren't as apparent to us as Gradle core developers as they are to you as big organizational developers, right? I mean that as big organization, not big organizational developers. Sorry, that's just Australian humour, sorry about that. And the file store and the binary store are co-located, which means the file store part, which is the part that you probably care about, it gets versioned effectively every time any of the binary format changes, even though it's had a fairly constant life in terms of its layout. So that's unfortunate, and it's something, yeah, it's just that it could be moved up as a sibling and it would be a better model there. Right, so where are we? Oh, we're almost done.
Real quick, I've got a quick question.
Yeah.
And this goes back a little bit where you could tell it to go into offline, or you could validate the cache and stuff. What do you do in the case where you've got like an internal Nexus repository or some kind of repository like that, and then when you're out in the world, you want to be able to do stuff and say maybe, well, I can't get to that internal server, so I just want to use Maven Central or something. Is there what's the best way of doing that, or is there a way to do that?
Not without changing, like, I mean, you can write some Groovy code to change the set of repositories you're using.
Right.
Is there a reason that you can't just use offline, like you actually want to add new dependencies?
It might be something I hadn't compiled anything yet, so I hadn't
Right,
put down those dependencies yet.
Yeah, no, there's nothing built in to do that, so yeah, except...
Couldn't you just throw your internal repository ahead of the Maven Central and it's going to resolve internally first?
You could do that, but I mean, a lot of people don't want Maven Central to be checked into source control, even if it's not generally used, right? You know, that would work to have, because it is a priority list of repositories. So, yeah. So I might quickly, maybe it's not even worth racing through this stuff. We've got 10 more minutes. So basically, some ways you can control dependency resolution. I just was going to go back. This is the same slide I showed before, just the steps to dependency resolution, and a few ways that you can manipulate what gets resolved. No, I'm not even going to do it, sorry. Shapan's going to cover that stuff tomorrow in his talk. He'll cover that sort of high, fine level control. I'm just going to quickly get onto conflict resolution because that's kind of important to understand as well. So what I've talked about so far, seems like I've talked a lot about it, but really that's just resolving single dependencies most of the time. So it's a dependency with either a dynamic or a static version selector will give you a particular module. Conflict resolution takes that to mean that currently applies to when you have multiple dependencies, each of which resolve to different modules and deciding which one of those to use. So Gradle has a built-in mechanism to do this. So by default, Gradle uses the newest version. It's the same algorithm that's used to select the newest for a list of modules. So these are two separate steps. There's a step here where we've got a list of matching versions and we're selecting a module version for that. That's resolving a single dependency. What I'm talking about now is once you've resolved two single dependencies and they come up with the same module, we then have to choose between those two. So we do conflict resolution at this point. By default, the newest is chosen, but you can also configure Gradle to say fail. Don't do anything in this case, because it's always possible to further upstream to affect this so this doesn't happen. You can always manipulate using some of the, like using forced versions or dependency resolve rules, which I had to skip over. You can use that to avoid getting conflicts. Some limitations to the way it currently works, which kind of can affect how people understand what's going on. I want to talk about a use case here. So we don't have, the conflict resolution process doesn't have access to what you originally asked for. It has access to what was the result of resolving those things. So when we have, if you ask for JUnit 4.1 and then something else says, I want JUnit 4.plus, what that means is first Gradle will resolve JUnit 4.1 to JUnit 4.1. It'll resolve JUnit 4.plus to, say, 4.3 that's available. Then what it's going to do is it's forgotten all this information here, and it's all it knows is I've got 4.1 and 4.3. What am I going to use? I'll use the newest, 4.3. So you can see why it makes that decision, but actually what version would fit those two criteria better would be 4.1. One says I don't care what I use as long as it's higher than 4. One says I want 4.1. So the best solution to that problem is 4.1. So this is kind of what we want to move to in the future with conflict resolution, is that it's important right now to understand why it chooses what it does, and that there's a two-step process in narrowing down the versions. So we take a dynamic version and narrow it to a single version, and then we take all those single versions and get the newest out of those. And I'd say in the fair distant future, we'd like to make it so that we have the full set of selectors and all the list of all versions available to make a better decision at that point.
So in this case, if the first one satisfies the pattern on the second one, you should always use the first one.
That's what we'd like for it to happen. In fact, we'd like it to be a lot richer than that. We'd like for conflict resolution to be, and dependency resolution in general, to be richer, for people to actually be able to declare much more than what they depended on. So I built my library with version, I tested it with 1.1 and 1.2. I know that it works with those two things. It should work with everything over 1 because that library developer says that they're backwards compatible. They use semantic versioning, so therefore it should work with those. And we've tested at 1.0 and we know it doesn't work. So so moving forward, where Gradle wants to go is a lot more metadata to allow dependency resolution and conflict resolution to be a lot smarter about these things. I think we were talking last night about I want people to be able to vote on how good a thing is. There's lots of information that's being lost here with this really simplistic model for dependency resolution. And eventually we want to allow rules to participate in conflict resolution as well. So sorry about talking about what we'd like to have, but got to get you guys excited about coming back next year. So, finally, that's it for me. Yeah, thanks so much for coming along. Sorry, it's a bit disorganised. I haven't spoken for a long time. So, questions?
The talk tomorrow, the dependency management in the real world, that's going to go into more depth.
You didn't see those 4 slides I flicked past? Effectively, he's going to go through forced versions, dependency resolve rules, exclude rules. That's so the high-level input you have into the dependency resolution process. Sorry, what's? Yeah.
Is there a switch to provide the repository URL when I'm running my Gradle command? And if so, will it be on the top of the list when there are other repositories in play, or will it go to the bottom of the list?
Well, the answer is no, so I don't have to answer the second question. There isn't a switch, but being groovy, you can set a project property and have if that project property is being set, add that in. So, and you can then choose whether you want it at the top or the bottom. Does that make sense? So because the Gradle script it's groovy, we could have in your repositories block, if project has property this, then set this repository here.
We have the deployment when the headers of properties of each user is dynamically provided to have the URL of the repository.
Cool. Yeah.
So a 2-part question. Is each configuration resolved independently?
Yes.
Okay, and then is it ever going to be possible for us to specify a different set of repositories per configuration since they're resolved separately?
We don't have plans to do that. I don't see why.
Would it be inherently hard? Or?
I think what we probably move toward more is moving away from configurations being such a core concept in Gradle, and it'll be it'll be when we start to say that's just an Ivy concept, and here's an Ivy dependency, and so it'll be a bit more rigid there.
Right, well, I could just tell you things like the FindBugs plugin, create their own config, and then add a bunch of dependencies that then get resolved against my repos. Yeah, I don't want that to. I want your dependencies to go to your places and my dependencies to my places.
So this is sorry.
Hopefully it takes that into account.
Sorry, I thought you were referring to Ivy configurations. You're referring to the Gradle configurations. No, and that is a really good idea actually to be able to say these dependencies, however they're defined, should be resolved only from these repositories.
Not necessarily dependencies, just a config, this configuration.
Except that usually what we do is configuration.all dependencies within, just so we can do it, because it gives them more flexibility. But you're right, yes. It'd be nice to be able to say, FindBugs should only come from the FindBugs repository and all of its dependencies as well. So, and it's not, it'd be kind of cool. Any more questions? Yeah.
You can have multiple dependency sections, right?
Yep.
Could you define a property on the dependency section to say all these things are changing, like to be able to toggle? Is that possible, or so you have to be able to toggle? So instead of like manually going through your build every time you're trying to do a CI build and changing all of your local artifacts to change.
What we would generally do is a lot of the time we don't have a defined dependency section, but we use some sort of input to create our dependency section. So it's an array of dependency objects that we then add to particular configurations. So you could have a set here. These are the changing ones, and when we add those, set the changing flag on them all. And when we add these other ones, don't set the changing flag. So it's definitely possible to do that.
Is there a plan to make the dependency management from Maven as a first-class equivalent?
No, not to use the dependency management engine from Maven. No. I think we're done. So I'll be outside. Come and have a chat with me, and we can talk about this stuff some more. Cool. Thanks a lot for coming along.